So today we're going to look at functions and operations with functions. So with a function, they can be added, subtracted, or multiplied. And below are how you would use each of those functions. So if we're given functions r and s, so remember these are different functions, then we can define new functions by saying function r plus function s, function r minus function s, or function r times function s, as follows. So you can see if I'm adding the two functions together and it's function r of x, s of x, well, we can separate those two out, just like we kind of have seen in the past, where we have function r of x, where the x is, next to the r, and it's also next to the s here. So we can separate them out with addition and subtraction. And with multiplication, we still separate them out, but we have the multiplication sign between them. So it's really kind of the same idea for any of these. So down here, they're going to give us the two functions. So suppose that the functions r and s are defined for all real numbers x as follows. So r of x equals 3x minus 2, and s of x equals x plus 2. So write the expression for r, the function r times the function s of x, and r plus s of x, and evaluate r minus s of negative 2. So now they're telling us what x is in this last one. So for the first two, it's just of x. So we're using a variable there, but in the last one, we're going to end up using an actual number for x. Okay, so let's go ahead and look at this first one. So we have r times s of x. So using that same idea up here, I'm going to split it into the two functions so that I have r of x times s of x. Well, I know what r of x is. It's 3x minus 2. So we can see that I've just replaced it. I've substituted it in. And then we know what s of x is. It's x plus 2. So here we see it again. So this is r of x times s of x. So now I'm just going to multiply. These are two binomials. So I can use a lot of different methods to multiply. I'm going to go ahead and start using distribution here. So 3x times x is 3x squared. And then I have 3x times 2. That's 6x, because 3 times 2 is 6. And now I'm going to scooch over to the negative 2 here, and I'm going to multiply that by both pieces in the other one. So negative 2 times x, that's negative 2x. Negative 2 times 2 is negative 4. The last piece here is just to combine like terms. And the only like terms I have here are in the middle, because it has to have not only the same variable, but the same exponent also. So x squared is not the same as x. But I do have 6x minus 2x, so I can combine those and get 4x. So I have 3x squared plus 4x minus 4. So that is the combination of these using multiplication. Now it's asking me to use addition. So I'm going to do that up here. So I'm going to separate them out again using this rule. So I'm going to separate the two so that I can see it's r of x plus s of x. So up here, you can kind of see my line following up here. So I have r of x, well, that's still 3x minus 2, and s of x, that's still x plus 2, but now instead of having a multiplication between them, I have a plus sign between them. So I'm not going to distribute like I did on this one, because that's a multiplication deal. On this one, I'm just going to add like terms. Since it's a plus sign, the parentheses don't really mean anything. Excuse me. It's just showing you, the parentheses are just showing you the groupings. But the plus sign is not going to change anything as far as when it gets distributed. A positive times a positive is a positive. A positive times a positive is a positive. If it were a negative sign there, then we do have to change all of the signs in the second parenthesis, because that does affect everything if everything in the second one is being subtracted. So just keep that in mind, the differences there. So I have 3x plus x, that gives me 4x, negative 2 plus 2. Well, those are opposites, so they cancel, right? So you end up with 0. So I just added like terms. All right, the last one, we have r minus x of negative 2. So now they're asking us to put an actual number in for x. So same thing, I'm going to separate out the two with this rule in the middle here, where I have r of negative 2 minus s of negative 2. So I have the functions separated. So when I plug them in, you can see I have a blue line coming over here. Now it's 3 negative 2 times negative 2 minus 2, because I put the negative 2 in here for x, for that piece. So I'm using the 3x minus 2, but instead of x, I'm using negative 2. And the same thing for s of negative 2. I'm going to have negative 2 plus 2. All right, so now I do have a minus sign here. That is going to change things. It's not like the plus sign where it doesn't affect anything. So now let's go ahead and use some simplification rules here. So we have 3 times negative 2. That gets me negative 6. The minus 2 comes down here. The negative is here, and I left this grouping together because this negative affects everything in that group. So if we notice in the group, though, it goes negative 2 plus 2. That actually cancels itself out. It ends up 0. So really, this is just going to be minus 0, and it goes away. So I just have to deal with negative 6 minus 2, and I get negative 8 minus 0, which is just negative 8. All right, so that is operations with functions. I hope that helped, and I will see you in the next video.